Alright, a calculator problem. We are told the daily temperature and the sales from an ice cream truck have been recorded in the table below. And we're told to perform a linear regression on the data and to write the equation. So we need to use our calculator for this. Things we need to know: temperature is our independent variable, our x values. Sales are our dependent variable, the y value. Think about why that is. The temperature outside will never depend on how much money some random dude makes selling ice cream. But how much money some random dude makes selling ice cream might possibly depend on the temperature outside. So we know temperature is our independent variable, our x values, and sales are our dependent variable, our y value. So we need to enter this data into our calculator. And to do so, turn the calculator on and hit the stat button. The stat button is found right there. Once you hit stat, you should see a screen that says edit, calc, and tests. Hit enter on the very first option, which is edit, because we want to edit the data table. So hit enter after you've hit stat. It should take you to a screen that looks like this: L1, L2, L3. Maybe yours are different. Maybe not. If they're different, come and see me. I can help you fix it. But we want to enter our data. We want to enter our X data, our temperature, into L1. And we want to enter our Y data, our money, into L2. Now, if you already have data entered, use the arrows to go up and highlight L1. If you hit the clear button on L1 and then hit down, it will clear all your data. Same thing for L2. If you move your cursor to L2 and hit clear and hit down, then it will clear all that data. And we want to enter our data. So move your cursor to the first slot in L1 and enter 85. Then we're going to type 85, and then we're going to type enter, and then we're going to hit 71, enter, and 84, enter, etc. We're entering all of our X data there. Once you're finished, arrow over to L2 and enter the Y data. So 200, enter, 160, enter, 170, enter, etc. Enter all that data. And once you have it entered, we want to perform a linear regression on that data. And to do so, you need to hit the stat button once again. So hit stat, and now we want to see that we have edit as an option, calc as another option, and tests as a third option. Those are the headers with different options underneath. Hit the right arrow over to go to calc, and go down to option, what should be option 4, which says lin reg ax plus b. It will perform a linear regression. Now, if you are on a TI-84 calculator with a new operating system, it will show you a screen that looks like this. It'll say xlist L1, ylist L2, freq list, and store reg EQ, and then calculate at the bottom. Now, since we entered our data up here into L1 and L2, X values in L1, Y values in L2, you should be set. That's why we chose those lists. If it says something different for some strange reason, put your cursor on your X list row, hit second, and 1 gives you list 1. You could do the same thing for Y list and highlight it and do second 2 to get L2. Frequency list, freq list right there, leave that blank. Go down to store reg EQ, and we want to choose, choose alpha, which is this green button right here, and then hit the trace button. You should see a screen that says Y1, Y2, Y3, blah, 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 and then some more right there. Hit enter on Y1. It'll put store reg EQ Y1 right there, and then move down to calculate and hit enter. Now this will calculate the regression equation. It'll tell you your coefficients A and B, and it will actually enter the equation into Y equals for you. Now, if you have an older calculator, a TI-83 or TI-84 that has not been updated, you need to do this a little bit differently. It's going to start out the same way. You enter your data just like we did above, and then just like we did on the TI-84, hit the Stat button again, hit the right arrow to go over to Calc, and then choose Option 4 to do a linear regression. Now this, on your calculator, will print ln reg parentheses ax plus b. Now what you need to do is you need to tell it to choose the x values from list 1. So hit second 1, and it will print L1 on your screen. And then hit the comma button, which is right above the 7, and now tell it where to get the y values from. So hit second again, and now hit option 2 to get L2. Do a comma again above the 7 button, and now we want to tell it to store this equation in y1. Now, in order to do that for you, you need to hit vars. This is the first button right there above the tangent button. On vars, hit the right arrow to go over to y vars, and then hit enter on the first option, which is function, and then hit enter on the first option again, which is y1, and it'll print a y1 right there. Then hit enter, and now it will perform the linear regression, and it will enter the equation into y equals y1 for you. So if you hit the y equals button, you should see that you get like a really gross equation that says something very close to y equals 4.191x minus 161.985. It'll look a little different on the actual calculator. Mine says 4.1910596777853x plus negative 161.98547764919, which is gross, and we are rounding to 3 decimal places. So we have our equation, and now option B says how much money does the model predict the truck will make on a day when the temperature is 100 degrees. So we need to remember that temperature are our x values, and sales in dollars are our y values. And how much does the model predict when the temperature is 100 degrees is saying what is y when x is 100. So we have our equation 4.191x, where now we're saying x is 100 minus that 161.985. And you can just do that by entering that into your calculator. And this model predicts that when it's 100 degrees, you will make $257.11. Now, another way to do that is to use the graphing feature of your calculator. And before we can do that, we need to adjust our window. So hit the window button, which is to the right of y equals, and think about what makes sense. X min, X max. Well, what are our X values? Our X values are the temperature. So maybe an X min is 0, because we're probably not going to be selling ice cream if it's below 0 degrees. We're probably not going to sell ice cream if it is 0 degrees, but this will at least show us what we want to see. What's a reasonable X max? Well, again, X is temperature, so it's probably never going to be greater than, I don't know, 130 degrees, so try that. But what about Y min? Y min, based off that data, look at the lowest Y value we ever see is 100. And that's when it's 68 degrees, and our X is going all the way to 0. So maybe we just go Y min 0. And Y max, let's try something. Maybe it's 130 degrees. Our graph's going to keep going up. So maybe we try something like $300. So enter that in, and we'll see what our graph looks like. I'm doing mine real quick. And when you enter that data, you should get a graph that looks like that. So maybe not the best window, but good enough for what we need to see. Now, another way to answer question B, once you've graphed it and got that window, is to hit the trace button, which is at the top. It's the top row button. It's the fourth from the left, second from the right. Hit the trace button, and then it'll plop your cursor on the graph, and now you can actually type in the x value that you want. And we want the x value of 100, so enter 100 and press enter, and it tells us the same thing. It says x equals 100, y equals 257.12. So we actually had a little bit of a rounding problem there. It should be 0.12. another way to get that same information. All right, so what about question C then? Well, question C says, if the truck costs $35 a day to operate, and the owner wants to make at least $50 in a day, ending the day with $50 in their pocket, what would be the lowest temperature that would make sense for the driver to operate the truck? Explain how you came to your answer. Well, think about what that's saying. We know that it's going to cost $35 to operate the truck, but we want to make a profit of $50, so we need to make $50 on top of the $35 that it costs to operate the truck. So if we want to net $50, we need to make at least $85. And since we're talking about dollars, we are talking about y values. So you could use your equation, and you could say 85 equals 4.191x minus 161.985, because we know that dollars is a y value. And we could solve this for x by adding 161.985. So 85 plus 161.985, and then dividing by 4.191 would give us x, and we could figure out that x equals roughly 58.932. Remember, we're talking about x values, which are temperature, so degrees. Now, another way you could do that is you could go back to y equals and go to y2 and enter the y value that we want, which is 85. On your calculator, we have our original y1 equation, and now it's going to also graph the equation y equals 85, which is a horizontal line, so your screen's going to look like that, and we can find that intersection by hitting second, calculate, intersect, which is option 5. Now, it's going to ask you first curve, which is saying what is the first line you want to intersect. Just hit enter if you only have 2 graphed, and then it'll say second curve, and notice that it automatically jumps you to the next equation, so hit enter again. It'll then ask you to guess, but there's only a single intersection point, so hit enter a third time, and it will tell you that the intersection happens when x equals 58.9315, which will round to 58.932. 2 different ways of getting the same answer. Now, questions D and E are quite related. D says, does this linear model make sense for all input values? Why or why not? Well, what are our input values? What are our independent values? Well, our inputs are x, which are standing for temperature. So no, this model does not make sense for all temperature values because the linear equation that we found has a domain of all real numbers. You can input any x value to it and get a real number back. But we cannot have all real numbers for temperatures. On Earth, we will never reach a temperature of, say, 778 degrees. Nor will we ever reach a temperature of negative 539,000 degrees. It's not going to happen. Our inputs are temperatures, and it will never reach crazy numbers like that. So no, it doesn't make sense for all inputs. So question E is saying, how could we restrict this domain to make it a little more realistic? Well, we found above that this dude's not even going to go sell ice cream unless the temperature is 58 degrees or above. So we could say that 58 is maybe our minimum x value that makes sense for this model. And then we could say that the maximum x value that makes sense for this model, well, what's the maximum temperature that is realistic on planet Earth? I don't know, maybe it's something like 130 degrees in the desert, and maybe this person sells ice cream in the desert. So maybe we restrict it like that. So we could say that our x values are coming from the set of real numbers, but we have the condition that 58 is less than or equal to x is less than or equal to 130. Maybe that's a realistic domain for this function.